Hi everyone. Today we are going to explore one of the most fascinating breakthroughs in the agricultural science. A technology that allows us to literally grow food in the desert. This presentation is titled Nanoclay, the liquid turning desert to farmland. And it blends both scientific analysis and poetic storytelling to show us how technology inspired by nature can transform barren lands into productive farmland. So let's dive in. Let's begin with an overview. This technology, nanoclay, it was inspired by an age-old fertility of the Nile Delta, where seasonal floods used to deposit rich clay and nutrients, making it one of the most productive agricultural areas in the history. However, due to modern interventions like the Ashwan Dam, this natural process was disrupted, leading to decreased fertility. Nanoclay mimics this natural process. It's a mixture. The nanoclay is a mixture of clay, water, and soil. And when applied to the desert sand, it coats each grain and allows it to retain water and nutrients. So in just 40 days, scientists in the United Arab Emirates managed to grow watermelons in desert soil. It's an incredible transformation that holds immense promise. How nanoclay transforms desert? Now, let's understand how nanoclay works in detail. So, when sprayed onto sandy soil, nanoclay binds with the sand particles. It's creating a structure that holds water and nutrients in place. The clay layer helps to mimic the effects of organic matter, which is crucial for the crop to grow. So, the best part is the crops can be planted just hours after the treatment, and there is no need for digging or plowing, which preserves the fungal networks like mycorrhizae, essential for soil health. Mobile nanoclay units make this method scalable, and tests have shown that it can reduce water usage by nearly half. So, it's a critical factor in water scarce regions. Although this is a scientific article, it uses beautiful language to make the information more engaging. Let's have a look at some poetic devices used in the article. First of all, there is metaphor from sand to hope. So, this metaphor shows us how nanoclay transforms not just soil but also people's aspirations and livelihoods. Then we can see the phrase like clay mimics organic matter. So, this is personification. It gives human like attributes to the clay, making the narrative more lively. Then we can see alliteration in the phrases like sand to soil, sweet watermelons, and these kinds of alliterations add rhythm and beauty to the language. Then we can see imagery. The article uses visual language, describing the ripe, sweet watermelons swelling under the Arabian sun, helping readers visualize the miracle. Such poetic storytelling helps us to connect emotionally with the scientific progress. Now, let's talk about why this matters globally. Food security is a growing concern worldwide, especially in arid regions like sub Saharan Africa. So, this technology can help to convert barren lands into productive farms. It will reduce the dependence on food import. It can be cost effective at scale. The price may drop to as low as $0.20 per square meter. And also, it can align with It can be aligned with major global efforts like the United Nations Great Green Wall Project, which aims to combat desertification. So, in the face of the climate change and growing population, nanoclay could be a key solution to the future food crises. When we are doing a detailed analysis of nanoclay technology, we have to break down the science further. First of all, there is a historical insight, the fertility in Nile Delta. That was due to natural clay deposits from river floods, the floods that happen in a river annually, occasionally. When that stopped, so did the productivity. So they built a dam over there, and after constructing the dam, the Nile Delta became infertile. Nanoclay utilizes a property called cation exchange capacity. Cation exchange capacity, which means negatively charged clay binds with positively charged sand. It will improve the soil chemistry. Then the soil ecosystem is preserved, like no tilling means fungi, bacteria, and other microbes remain undisturbed. So we are just spraying it on the surface. And nanoclay is not one size fits all. Every type of soil requires a tailored mixture. So it needs a customized formulation. Nanoclay is under a customized formulation. Then it enhances the root zone, allowing fast planting and yield. This shows that the solution is both natural in concept and engineered with precision. While nanoclay is remarkable, let's say that nanoclay is remarkable, but there are other soil improvement techniques too. The first one is biochar. So biochar is a charcoal like substance which is produced by burning organic matter in low oxygen environments. Burning organic matter in low oxygen environments, which is known as the process of pyrolysis. And it is rich, biochar is rich in stable carbon, which will be improving the soil structure, and it will help to retain nutrients. So it's especially useful for degraded soils or those affected by mining. Then we have vermiculite. Vermiculite is a sponge-like mineral. It is a sponge-like mineral that absorbs water and slowly releases it. So it will be enhancing the soil aeration and moisture retention. Both methods have their own applications, and sometimes a combination of technique works best depending on the region and soil type. Let's summarize the key benefits of using nanoclay. So first of all, it converts barren deserts into farmland, and it saves up to 47% of water. That's a major advantage in dry climates. And it is an eco-friendly process as it preserves the existing soil structure. It doesn't affect any microbes. Then it is working quickly. The crops can be grown in few days. Then mobile units are there, so they make deployment efficient and scalable. And with mass production, costs can come down, making it accessible globally. And all of this make nanoclay a game-changing innovation in the sustainable agriculture. Like any other new technology, nanoclay has its own limitations as well. So first one is the current cost is really high. It's almost $2 per square meter, and which is not affordable for smaller farmers in poorer countries. And it only works well on sandy soils, not clay or saline types. It only works well on sandy soils because of the cation attraction. Then it needs reapplication every 5 years to maintain effectiveness. So it gives a guarantee of 5 years. So after 5 years you have to reapply it. Then it requires an initial soil testing and tailored formulas, and scaling up requires infrastructure, training, and logistics. So this technology is still young and more research is needed. These challenges must be addressed for Nanoclay to reach its full potential globally. To conclude, Nanoclay represents a powerful blend of ancient wisdom and modern innovation. It revives degraded soils, saves water, and brings food production closer to communities that need it most. Its potential in fighting global food security and climate change is immense. But but we must also consider cost, limitation, and alternatives. So I have two questions to ask you, which you have to discuss on your own. First of all, do you think Nanoclay could revolutionize the farming in your region? And can you think of other fields where this principle of nature inspired innovation could be applied? And that's all for today. Thank you for listening.